Now let's take a look into the future. What's predicted for changes in vegetation as a result of climate change? Well, a few things could happen. On the long term, when we talk about long, slow climate change, which has happened over thousands of years in the past, we see that plants and vegetation can actually migrate to different regions. They can go to higher latitudes if it gets too warm, or they can go up mountains or to lower latitudes if the climate cools. And so we can actually get migration of species over very long distances if the climate change is slow enough. But when we have short-term rapid climate change over decades or hundreds of years, is what we're actually seeing today, it often is much too fast, much too rapid for this natural migration of vegetation of different species, which basically means that we're going to see the extinction of many species, many plant species, because they cannot adapt to this rapid climate change which is occurring all the time. If we look at studies of migration of various species, it occurs at a rate of maybe tens of kilometers every 100 years, every century. So if the climate is changing slowly, we'll see the movement of different types of species to more favorable regions, but this takes a long time. Only 10 kilometers they'll migrate over 100 years. But in the future climate, we're expected to see things changing. We'd have to have migration rates of hundreds of kilometers per century. This is basically impossible on a natural basis for plants to move hundreds of kilometers every 100 years, again, implying that we'll see maybe extinction of many species. In addition, today, we have fences around park areas or natural vegetation. So if the vegetation wanted even to move north or south out of that boundary, there's a city there, there's a road there, highways, and therefore there are additional factors which won't allow it to move. The figure we see on the right here shows about the 21st century sensitivity of vegetation to climate change, where when we go to higher numbers, 80%, 90%, it means that 80-90% of the plants in that region are going to have to adapt to climate change and are going to be very sensitive to climate change, compared with areas which are already hot, for example, desert regions around the Sahara Desert and on the boundaries of there where we already have very dry vegetation and it gets a little bit hotter. The plants will most probably not have to adapt too much because it's already hot. But when we go to places which are cool, like northern parts of Asia, Canada, there we're going to see that nearly all the plants in that region are going to have to adapt somehow to climate change in the future, or they'll go extinct. And basically, if we want to maybe help the vegetation, we may have to plan for the future. And if instead of just letting the vegetation migrate by itself, we may want to replant forests or vegetation in new areas to help them, keep them alive, and to help this kind of artificial migration of vegetation to higher latitudes where it's going to be warmer in the future. So we can talk about latitudinal variation. We can also talk about vertical migration of plants. If we could look at this mountainous region, as we go up in altitude, we also have cooler weather, lower temperatures, and so we also see changes in vegetation as we go up in altitude. And as the climate warms in certain regions, we're also going to we'll see the migration of different species going up mountains. And here you can see this animation from 1860 for a region in the Glacier National Park in the US, how vegetation has been changing over the last 100 years. You can see the white areas or the snow-capped mountains are disappearing, and the different types of vegetation and the grasslands from lower altitudes are moving up the mountains to regions which are cooler to adapt to this climate change. And this is being seen around the globe, that you can see this migration both up in altitude, but also a change in latitude of different vegetation types. If we try to simulate what may happen to certain types of trees and forests in the future, you can see here an example for a spruce tree, the sticker spruce tree seen in the picture. These four different panels show on the left-hand side, we can see where we have these trees in the northwestern US and Canada border in the present-day climate. You can see it's mainly around Vancouver Island, Seattle, the border of Canada and the US. The second panel shows the simulation of where we would expect those trees in today's climate, and so that agrees fairly well with the observations. The third panel shows where we expect those trees in a future warmer climate, where we double the amount of carbon dioxide in the atmosphere. And the fourth panel is looking at the difference between the two middle panels, where the blue areas show we have an increase in the spatial distribution of this tree, and the browns are a decrease. So for the spruce tree, we actually see that increasing carbon dioxide and maybe warmer temperatures is actually good for these trees, and they're going to actually spread to much larger areas in the northwestern part of the US. But if we look at a different tree, and here we have the Douglas fir, we can see again the observations on the left. The second panel is the simulations from the model for today's climate. The third one is the future distribution. And the fourth one is the difference between the future and today. Now we see a lot more browns and less of the blues, implying that there are going to be many areas in the future where we won't have the right conditions to grow these trees. And so these trees are actually going to disappear from the environment in these regions if the climate goes forward with a doubling of CO2 with all the associated warming and changes in rainfall patterns. What about other biodiversity related to the biosphere? So it's not just the plants, but we can look at insects and vertebrates. So here we can see on the left what we could expect to see the loss of biodiversity if the global temperatures increase by up to 1.5 degrees. And then on the right-hand side, if we go above 2 degrees. So we can see that we're going to lose maybe 18% of all the insects on the planet when the temperature rises, the global temperature rises above 2 degrees. Maybe 16% of the plants are going to go extinct, and even 8% of the vertebrates, which can migrate much faster than plants. But we're going to have a great loss in biodiversity, also a result of climate change. And then the signs that climate change is happening and the impact on the biosphere, we can see all around the globe. A few examples here, say the tree line, where we see trees growing in the mountains, and above that altitude, we don't have trees because it's too cold. We're seeing in many places around the globe, Europe and New Zealand, we're seeing a shift of the plants going to higher altitudes, a sign of warming. We're seeing the tundra vegetation expanding northwards in the Arctic. Alpine plants all over the world are moving higher up in altitude, sign of warming. We're seeing the spread of vegetation and the biota in Antarctica, which is a sign of warming. The zooplankton in the ocean. Butterflies are flying further north during the years, a sign of warming. Birds are expanding their migration paths, going to colder climates, going further north. And even looking, say, foxes in Canada are going further north every year because the climate is warming. So there are many, many signs that the biosphere, both plants and animals, are already responding to changes in the climate, and it's just going to get more, we're going to see more and more of this happening in the future.